Hello, my name is METİN Arıdaşır. This is 411th part of explanation of my theory. Here is my shortest shortened wavelength formula for an accelerated electron by applying voltage. Yes. I will explain this formula that I put forward step by step. My Vx k equals k 2 pi c formula, which is tangential speed of any point. This point, inseparable imaginary point, photon, on the motion surface of electron and its consecutive waves, k wave number. This is my formula, tangential speed formula. Tangential speed which is equals to 2 pi c 1,884,000 km per second, or 6.28 times greater than the speed of light. Tangential speed. Vg, 2 Vg, 3 Vg. Okay. Yes. According to me, volt is an energy unit, and 1 volt equals to 10 to the minus 19 kilometer square per second square, or joule. According to me again, Planck's constant h is L. Angular momentum of a photon, an inseparable imaginary point on the surface of an electron or its waves. I hope you see. When an electron is in motion, for each point, wavelength, wave velocity, light wave velocity, mass, energy, etc. change. In 0 degree direction, this is electron motion forms motion direction. And here, shortest shortened wavelength for a point, for a photon, because photon is inseparable, and inseparable every point on electron motion form. Here 0 degree photon, 30 degree photon, 180 degree photon, cycling. Yes. When an electron is in motion, wave-point velocity, photon velocity, wave-point wavelength, wave-point energy, wave-point mass, etc. change depend on the wave source. Electron is wave source. Wave source, electron velocity, motion direction and orientation without frequency change. Here there are my formulas. Here frequency doesn't change. Okay. Variable velocity of light formula that I put forth, variable wavelength formula that I put forth, and here constant frequency formula that I put forth. Variable light speed, so light velocity, variable wavelength, but constant frequency. Okay. Now, when voltage is applied, the electron as a light source gain speed. Like what? Like this. Gain speed. According to me, as the velocity of electron increases, in the motion direction at the rate of its velocity, wave-point wavelength shortens. Here, 0 degree direction, it is shortest shortened wavelength of an electron and its waves. Here, As can be seen in the continuous spectrum graphs, the fact that the minimum wavelength approaches zero as the voltage increases is one of evidences of Fermat theory. Here, for 10 kilovolts, this is shortest shortened wavelength. 20 kilovolts, more accelerated, more gained velocity electron approaches zero, more shortest shortened wavelength. 30 kV, more shortest shortened wavelength approaches zero, like this. Here, then. Minimum wavelength is nothing but the shortest shortened wavelength of waves in 0 degree direction, motion direction of electron. Lambda minimum is equals to lambda minus delta lambda cosine 0 degree is equals to lambda minus delta lambda. Here, graph like this, an accelerated electron in 0 degree direction, wavelength 30 degree direction, different wavelength. 45 degree direction, different wavelength. 90 direction, different wavelength, but frequency doesn't change here. Okay, then finally my shortest shortened wavelength formula for accelerated electron related to voltage and gained velocity here. Lambda minus delta lambda equals to this. Vg is 2 pi c. 1 volt is 10 to the minus 19 joules. Final formula, here it is. Coherent formula. Have a good day. See you later.